So my name is Adan. I'm the CITO for Ciena. Thank you for all attending this session. I'd like to talk to you a little bit about automating today's network, really to derive outcomes for tomorrow's transformation that we're all focused on here today. You know, Ciena is really well known for being an industry leader in networking technology, and effectively you could summarize our strategy as kind of two parts driving customer outcomes. First of all, we're all about moving the bits, and we move a lot of bits. You know, very high-speed optical transport networks were extremely well known for that, well established for a very long time. And with the integration of our Blue Planet software application portfolio, we're really now focused on automating networks while we're moving a tremendous amount of information across service provider infrastructure. Really all focused on driving measurable business outcomes for the carriers, for our customers itself. And I think we're really fairly well known for that. If you take a look at today's networks in the view of SDN and NFV in this conference, you know, we've moved a long way towards simplifying the network and looking at, you know, how can we create a connected world of interconnected clouds with virtualized infrastructure, software-defined networking. And I think we've really made some tremendous improvements. However, if we take one layer lower to kind of layer 2 and below, it's still an extremely complicated world that we live within. And there's a lot of work to do to take that infrastructure, which really provides the substrate, really provides the capacity that fuels our software-defined networking and services and cloud infrastructure to the next level. And how do we do that when we have a network infrastructure which has been developed over a very long period of time with a large set of technologies? And we had to deploy those technologies over the years because of the advent and evolution of technology, from SDH to SONET to sort of WDM and optical, and then finally Ethernet and then beyond. But the challenge we have is that whole estate of investment still persists. It still exists. It still provides you the capacity that you're utilizing for your SDN network. We would argue that it's time to now look at that infrastructure and try to bring the concept of SDN and software-defined networking to it to create a greater level of agility. And yeah, the systems that manage that transport infrastructure many times are still developed in like 1980s technology. This is an example of what COBOL looks like when running on IBM mainframes. This is the state of the art, if you will, in a lot of transport operations organizations around the world. And there's some very famed systems around that you can Google about those. But there are tens of thousands of people involved in manual processes, in some cases mechanized processes, but mostly manual processes, using systems developed in legacy technologies and applications with very low or no automation. We really think there's a lot of room for improvement here, okay? And so we're interested at this point with Ciena is how do we take this current infrastructure environment and move to an environment which is converged packet optical, providing the resources, the actual capacity to the SDN, NFV world, cloud-dominated world that we all live in today. If I turn our attention to automation, automation is not a new thing. Automation has been occurring for a very long time across every industry, sort of from the craftsman all the way through assembly with repeatable mechanized tools to advanced production. The challenge we see with automation, the evolution with automation, is that it's still driven by people-oriented processes. If you look at how Ford Motor Corporation makes cars, they make cars like people used to make cars, but with machines. Is that the most efficient way to make the car? We don't know, but we're doing it based on a well-defined, repeatable process that we've all become comfortable with about how to make a car. If I turn that analogy sort of toward the networking organization or the transport organizations in operations today, many systems have hundreds of bespoke custom rules for the best way to define transport services, the best way to plan, engineer, design, route, capacity around the network. But those rules have been developed over a long period of time by people experiences. Those rules may not necessarily be self-accurate with one another. Do we really know that those rules are the most effective way to deploy capacity? We'd argue that maybe not. But by introducing intelligent automation, introducing big data analytics and machine learning technology to define the rules by which we plan, fulfill, assure, and close the loop of the network, the transport network, we believe we have a much better chance now to truly deliver that agile infrastructure with the lowest cost per bit that you're looking for. You know, there are many factors driving the change and the need for automation now, and I think you all know those probably better than me. But the thing that maybe not as known, you know, all the way from user requirements through new technologies, through machine learning technology becoming available, it sets an expectation for how this industry needs to perform, with at least within the stock markets. They expect us to get more efficiency. They expect us to deliver more for less constantly and to do that in a more dynamic, real-time way. But what may have been missed at times is all of that places more and more demands on that transport network, on that infrastructure network, if you will, which really has never been reimagined or refactored. In my last job, I ran development for an IoT company. We would refactor our applications on a quarterly basis. Refactoring means do it again, rewrite it, write it in a more efficient way, figure out the next best process. Most of these systems have really never been reimagined. They've just been augmented or patched or changed around the edges. And we think there's an opportunity now, with the technologies available, to really reimagine transport orchestration and operations. These terms are just for the user. But there's a lot of use for the word orchestration, intent-based, analytics, machine learning. And fundamentally, we believe that if you incorporate all of those together, you come to an idea of intelligent automation and software-defined networking, utilizing real insights and real information and real data to drive the fulfillment, assurance, and closed-loop processes. I think that, you know, we would agree that there are some key components to closed-loop automation. You saw a different representation from Patrick, but the idea is similar. At the top, we sort of have this intent-based domain or orchestration environment. We sort of have SDN controllers. There'll be many of those. Those will be provided by equipment manufacturers probably, or at least in most part. We have analytics, which will drive the fulfillment process and drive the assurance processes based on real data and real intent. And of course, we have network resources. But what many times is missed is in the middle of all of this, we have people. Real people every day trying to deliver services to our customers and to do so in a professional and repeatable manner at an appropriate cost profile. And those people have processes. And so whatever we do, we have to intersect the fact that there are well-established methods and mechanisms to operate networks, and intersect the fact that we have a tremendous legacy investment, and use that infrastructure to migrate to a more converged world, a more agile world of transport operations and networking. If you take a look at our portfolio, we really provide all three of those aspects, and of course we do provide the networking aspect itself, at least for transport. That said, we're fully open, fully microservices based, fully scalable, fully not only for Ciena equipment. And we think that's really what's required. It's taking a more domain-centric approach for transport operations and really closing the loop, if you will, between analytics, assurance, and fulfillment. So why automate operations now? You know, fundamentally, when we speak with our customers, we realize that networks, and we're really interested in network modernization and evolution, they can really only evolve at the pace of operations. It's fantastic to deploy new network equipment, but you really don't want to create another IT project, which is 2 years long, that creates another bespoke fulfillment and assurance stack by doing so. Instead, what you'd like to do is sort of burn down that legacy as you introduce new networks and services, and to use automation to make that transformation. So network transformation is one key reason to drive automation and derive this sort of automation strategy for your customers. Again, we want to see a future where all the legacy leaves our network over time. But in that time, we don't want to disturb our customers and disrupt our business. Clearly, we want to improve operations. We want to reduce the total cost of operations. I think that's a challenge that we see in general. There aren't a lot of good models on how to operate efficiently the next generation network, transport, or SDN. And the modeling for that really has not been done. We spent all of our time looking at how can we get the lowest cost of delivery, the lowest cost of equipment, the lowest cost per bit. But in fact, we think you need to look at the total cost of operations and the equipment and take a look at a rational approach for the evolution. Clearly, there's network planning and operations benefits, and there's more network operations benefits as well. If we take a look at sort of the stack, if you will, of the present mode of operation for fulfillment systems, not referencing any one portfolio, but I've got a lot of experience with the software portfolios and fulfillment, a lot of you would know. They're very top down. We have our lines of business at the top, wholesale, retail, whatever it might be. And then we have a set of fulfillment stacks, each one of those replicated for a particular service, all centered around inventory, all centered around product and service catalogs and decomposing orders and assigning information in the inventory system. And oh, by the way, the inventory is not accurate because it's not a live network view. So then we create all sorts of systems to discover and reconcile the inventory to the network, because you can't fulfill a service if you don't have an accurate view of inventory, right? The consequence of this is that while it was very appropriate at a time when networks moved at a different rate, when we were deploying 1-2 services per year, today we want to deploy a vast number of new services all layered on top of each other and use virtualization, which means that many of these services and networks only live for a short period of time. And the consequence of this is that it's inflexible. And one change in one system ripples across the entire stack and has all sorts of unexpected consequences in assurance, in the testing and what have you. So our idea is, what if we use orchestration to intercept the fulfillment and order process, to use this closed loop automation idea to actually transform the network and transform the operations, to federate, to encapsulate the legacy OSS stack, and over time, shrink it and make it smaller and make it more real time and make it act more like a software-defined network instead of operation systems for it. We fully recognize that there's a role for inventory because not everything is live in the network and not everything can be discovered, and that's clearly the case in transport. But the inventory we have in the future should be more of a database of record for assurance and a database of record for the design of the network, not the central point for all fulfillment activities. And as a result, we can get out of the business of reconciling to a model that will never be up to date. This outcome is we end up with a more encapsulated intelligent automation platform. For all of you with computer science degrees, you might recognize this game, or at least you might have played children's games. This is the Tower of Hanoi. The rules of the game are simple. The goal is to move all disks from one pole to the other, never putting a larger disk on top of a smaller disk. It's a fun game. It's kind of like CS 101. It's sort of one of your things to do. If you take a look at networks, they're kind of like the Tower of Hanoi. They're very stacked and very layered. And even within these layers, they're stacked and layered, especially in transport, because of time. We introduced point-to-point services, wasn't good enough. We introduced ring services. Well, that wasn't good enough either. We introduced 4-fiber ring services. We never got rid of the point-to-point. We introduced mesh. We introduced all the transport layers on top of each other. All of those stranded capacity over time, and all of those led to a totally more complicated OSS environment and network environment. We believe the industry really needs a radical change, okay? We believe you need more agility. We believe you need to be able to create more services and more tailored services in a more rapid manner, and to do so also by, at the same time, reducing operational expense. If you go back to the tens of thousands of people in operations for transport operations, that's a pretty high cost to bear to manage an estate which is actually making you inflexible, okay? We also recognize there's always a push for more capacity and more lower cost per bit services. As I said, if we focus on total cost of operation and not just cost per bit, you can really look at the business case impact of introducing a new network technology, not just more capacity into the existing environment. So our algorithm, if you will, first of all, is to increase automation at the bottom of the stack, okay? Whereas today it's very manual and very physical and very labor intensive. To reduce layers at the bottom of the stack through migration, through network transformation, through orchestration, and through fundamentally encapsulating the legacy provisioning systems and migrating them out, and migrating the networks that they manage out toward this world of a converged packet optical core. There's a tremendous greater amount of OpEx spent in the bottom layers of the networks, and you can look at now analyst reports to prove that. Just look at the amount of headcount allocation per network service delivered, and you'll find that tens of thousands of people at the bottom. So if you focus at the bottom, you can really move the needle, if you will, from an operational cost point of view while you're introducing greater agility. So our algorithm, if you will, is to encapsulate the legacy environments. We think that the role of traditional provisioning systems and fulfillment systems in this layer needs to change. And we need to take a more network-centric approach. We believe to consolidate the layers of the network, it's time to take the unneeded layers of transport technologies out. Those layers were added for expedience, not for efficiency. So when you use circuit emulation to put DS3 over STS1 over SONET over WDM, doesn't the customer just want a 1 gig service? You know, and wouldn't they be happier with that? And wouldn't that be simpler for you to manage and simpler for the automation to deal with? Of course, that's what they want. This approach gives us a way to get there while not disturbing the customer experience. And finally, we want to iterate to this final state of an automated, converged packet optical infrastructure. So the whole idea of intelligent automation, eliminating time, process, people represented by OpEx, giving those people hopefully better jobs to do in the future versus managing the history of legacy and COBOL environments. That was my comments for today. Thank you very much for your attention. We do have a booth and certainly would welcome anyone to come by and have a chat. Thank you.
Thank you, Ed.